Alright, so I took the little combo gun out to the range today for the first time and had a shot with a 22 barrel. There is one problem with this gun still. So I actually left it like this when I came home, just to be able to show you, to film it. As you can see, I've left a fired case in the chamber. These are federal standard velocities. So you can see my horizontal firing pin mark on the case there. But as you can see, it hasn't actually ejected. Now, what I was having to do, you see that they've actually provided this little thing here to aid ejection if necessary. So what I was having to do, luckily I took my little Lyman hammer, has got a brass end on it. I was having to just, it's a bit difficult to do this, but it's coming out that. As you can see, it's coming out. Still tight though, so you're still, oh there we go, I managed to get a grip on it and pull it out. So I did fire some shorts, fired a couple of them in it, and they obviously don't create the high pressure that the Federals do, and they actually extracted fine. Now if you look at this extractor, it's actually spring loaded. So as you close the gun, the breech face pushes the extractor in. So it's not actually a positive extractor that actually uses the mechanical advantage. I suppose because it's up on the rifle barrel and it's very difficult to get some sort of mechanical system like you do on a shotgun. You know, there's actually a rod that actually, as you open the gun, a bit on the fore end pushes a rod and pushes the extractor and extracts. That's probably how this bottom one works. However, this top one is just simply a spring loaded, quite a tough spring. So there's a fair bit of spring pressure. If we look at the chamber here, you can actually see, actually it was probably easier to see when the actual case was in. I'll shove the case back in again. Can see if it'll stay there. So I find myself a point. Here we go, there's a little jag. You can see that dimple there. See, I've actually put the case in different ways. The firing pin dent's up here. But the firing pin dent now is just here, but you can actually see a dimple there from when the old firing pin was in here. So what you've got here is a peened edge of the chamber. So it's a bit hard to tell, but you can actually see, so there's actually a slightly peened bit on the extractor itself, but then just in there you can sort of see, it might be hard to see from this distance, and I can't get any closer because it won't focus, but the edge of the chamber has just been peened by that firing pin striking it and moving a little bit of metal into the edge of the chamber there. So it's a very common problem in rimfire rifles. So and it will cause two things. One thing, it will, in extreme cases, it will cause the edge of the chamber to be such that a cartridge won't be able to slide into the chamber, and so you'll have trouble actually loading or feeding. But in mild cases, they may, because of the tolerance between the chamber and the cartridge may go in okay, but then when it fires, the expansion of the brass means that the cartridge actually expands behind the little lip created by the peening of the edge of the chamber, and then of course it won't come out. Still haven't tried this. It's not going far enough back to flip the case out now. So what's happening with this pistol, and you'll fire this pistol, will fire 2 or 3 shots, it'll cycle perfectly. Now that I've fixed the ejector, which you'll see in one of the my previous videos, but then it would do one of 2 things. The most annoying thing it would do is you'd fire it, and then when you went to fire it again, nothing would happen. The bolt would be closed. You pulled the trigger, nothing would happen. And when you pulled the slide back, you'd realise that you could tell by the weight of it that it wasn't actually cocked, and the case was still sitting in the chamber. Now, anyone who knows anything about this type of pistol knows that it's a simple blowback design, so the actual recoil of the fired cartridge actually pushes the slide back and cycles it. So if the cartridge is not coming out of the chamber, there's obviously something quite tough holding it in there, and really the only thing that can cause that is a hook on the edge of the chamber caused by peening. Now the other thing that it does when it does cycle, well, sometimes it cycles fine, but we're also getting a few stovepipe jams where the case doesn't clear the slide before it closes. Now that can be caused by a variety of reasons. And the ejector works well, the extractor works well. There's no reason for getting stovepipe jams. What I suspect is happening is when it is actually managing to pull the case out of the chamber, because of the drag of the hook on the edge of the chamber from where it's been peened, it's not pulled out as quickly or as effectively as it normally is. So that slows because the frame has to, well, the frame's not pulling, the case is actually pushing the frame back, but because of that drag, it's not pushing the frame back, the slide back as enthusiastically as it should, and therefore the case is not clearing the pistol before the slide comes back again. So what I'm hoping to be able to do is to fix this chamber, get it so that the cases smoothly come out and cycle the action, and then it'll hopefully smoothly re-chamber the next round. So anyway, we'll get on and do that. So here we've got the chamber end of the barrel from the High Standard Supermatic Citation. Now you can see the firing pin mark on the rim of the chamber here. If I measure across this way at kind of 90 degrees to the peened chamber, we get a reading of, so it's about 2 7, somewhere between 227 and 228. Now if I turn this 90 degrees and then I actually measure across the peened part, you see that's a touch less than 225. It's about 224. So it's about 3 thou difference. So I think what I'm going to do is I'm going to try to make this ironing tool initially maybe about 0.2275. So that should be enough so that it should go into the chamber, but it'll be a bigger diameter than the actual peened edge of the chamber. Now to repair this, I've never done it. I'm quite familiar with the process because I've seen it in plenty of gunsmithing books. You have to actually use what's called a chamber iron, and what that is a little tool that's approximately, the end of it's approximately the same shape, size and shape as a 22 case, but it has a very mild taper on it. It will actually displace the steel that's been peened back into place and make the chamber round again, take that lip off. Because the last thing you want to do is file or do anything. That's what people do. They try to fix them by removing metal, and then you can just bugger up the chamber and there's no going back from that. So whereas this soft steel, you can just iron it back in place. Now, there used to be a company or a guy in the US called Tom Menck, I think his name was, M-E-N-C-K. He used to make a tool specifically for this chamber iron. He used to make a variety of tools. He used to sell them on Brownells, but I noticed all of his tools on Brownells are just listed as no longer available. So I'd say he's probably gone out of business or got old, stopped making them or something. However, apparently you can make your own. Now I've got a whole variety of gunsmithing books, and I do recall reading in there there's actually some drawings of how to make one. So that's what I'm planning to do. So I'll have to get some hard tool steel and or drill rod or something like that, and then make a handle and turn it up on the lathe and heat treat it and see if I can make one of these tools. I've got this one, and then there's actually there's a high standard pistol that I've been fixing for someone, which also has the same problem. So I've got two guns to do. So yeah, so that's what I'm going to do. Now in Dunlap's gunsmithing book, they talk about using drill rod to make the chamber ironing tool. They talk about drill rod for making a lot of different tools in those American gunsmithing books. And you look on the Brownells website and various other American things, and they often talk about drill rod, which is obviously the stuff that twist drills are made of, high carbon steel that can be tempered. That can be hardened and tempered so that it has a cutting edge. Now here in Australia we don't seem to ever have this drill rod. That's not a name that they use. I asked at my local engineering supplies to see about getting some high carbon rod, and they really didn't have anything that was comparable. So what I did was, as I always do, get on eBay, and I actually found a place in China that has, they call it drill rod. Now, I don't know what alloy it is, I don't know how easy it can be hardened, I don't know anything about it, but that was like $5 with free postage for a 6mm by 200mm piece of rod. I bought a whole heap of other different sizes while I was there. So, but anyway, at 6mm, it's pretty much the right size. Let's just get it out of the packet. So that should be suitable for turning down. So I'll turn one end down about the length of a 22 chamber down to 0.2275, as close as I can get it to that. Right, I put this rod in the lathe to start machining it, and I realised it's actually pre-hardened. So it's basically like a drill bit. So I've actually had a go. I've heated just this first probably 3.5 inches to glowing red heat, and then let it slowly cool. So hopefully it'll now be machinable. Right, that made a bit of a difference. It's now cutting okay. So what I've done is I've just started machining it, and I've just machined it to the depth of the 22 chamber. Well, the shell anyway. So because I just want to make sure that if I'm pushing it in, you know, it's not gonna, there's no way it's going to be able to go too far and damage the chamber or anything like that. So as long as the actual machine part, which is the same diameter of as the case, is as long as the chamber, well then it can't cause any damage. So now I'm just going to, I won't film this because it's I'm just going to have to very carefully machine this to the correct diameter. Okay, so I've turned the end of this rod after annealing it, softening it. I turned the end of this rod as close as I could get. It actually is 0.2770 on the end, and then up at this part here, it's the end of it's the same length as the 22 case. It's up about 0.2275. So it's about as parallel as I could get it within 10,000 or 5/10,000ths, which should be ample for what we're doing. So what I'm going to do is now I'm now going to I want to round the end of this. Now I think the easiest way to do it, my lathe's set up so I can actually turn the headstock of my lathe to cut angles. So what I'm going to do is I'm going to just cut a 15, which will just take the corner off, then a 30, then a 45. We'll do 15, 30, then 45, and that'll give 3 facets, which I can then use to file into a dome shape. So we'll do that now. Alright, so I've set the headstock up 15 degrees there. So I'll just take the corners off this. Alright, so there we have it. I've finished turning the end on this. Now I'm just going to take it out to the lathe and put that little flat spot on it. Alright, so we've ground our little tool here. So it's basically about the size of a 22 chamber, 0.227 I think it is. Now I don't know if you can see here, you can see the point where the firing pin's been impacting. So we'll just put this in the aluminium vice jaws. Now I've ground the other end, so approximately square. So it will go in a die holder, a tap holder. And so what we'll do is we'll start with the flat part against the, so that the flat part's facing the bit that where the dent is, and we'll just gently do a bit of a turn. Now it's actually slightly tapered this, so I made this a lot longer than I needed to because I figured while I'm making one, I'll make one that's long enough to use like in a bolt action rifle. Right. All right, now that actually worked a treat. Yes, I just put some oil in the end, put it in, pushed it in till it was just a bit tight, and then started turning it while I was still sort of gently pushing. I never had to use any force, and I could actually feel it kind of, it's hard to describe, I could feel it pushing around against the edge of the chamber. Now if you look in there, you can actually see where that first little bit of the chamber is shiny, where it's turned around. Now I'll grab this between my legs again, a sort of age-old problem as filming with an iPhone. Now last night, I should have actually filmed this, but last night I was actually getting this brass rod and going like this against that peened edge, and I could actually feel there was a spot where it got caught, which is obviously the spot where the case is going. But that's fixed that now. So that just goes straight there. So that worked amazingly well. Of course, the proof will be in the pudding when I actually shoot it, but I reckon that that's going to solve that problem. Now we've done the chamber of that high standard, we're going to turn our attention to this combination gun. So as you can see, it has this spring-loaded extractor. Now that's all that there is to extract the case. So if the case is stuck so much that that spring can't overcome it, then it won't come out. Now you can see where the peening is. It's actually just on the edge of that extractor as well. So what I'm going to do now is I'm going to take the extractor out just to get it out of the way while we do this job. And we'll fix the chamber hopefully. And then I think I'll just have to have a really close look at the extractor and possibly just use a tiny file just to take the peened edges off the extractor, and then hopefully it will then extract effectively. So to take the extractor out shouldn't be too hard, I don't think. Just need to, you can see there's that little screw. Now that's going to be under tension because that's what's going to stop the extractor coming out. So that's going to be a two-handed job. I'll just push the extractor in and undo that screw, and then I think the extractor will come out with a spring behind it. Right, so I took that screw out and I pulled the extractor out. Now the extractor was actually quite tight in that hole, so it probably could do with a good clean and oil that hole, and that will probably increase the extraction efficacy and pressure against the case. So the spring is actually still down in the hole. I'm going to have to find a little tiny bit of wire to put a hook on the end of it, and I'll shove it down there and pull the spring out. But anyway, you can see without the extractor, I don't know if you can see, without the extractor, you can actually see the peened edge on that chamber. See, just right on the right hand side of the extractor cut, you can see, and you can almost see the little bit of metal that's been pushed out into the edge of the chamber. So I'll just put that there, and I'll grab my bit of brass rod. Let's see if I can feel that. You can feel that. See, if I slide that up there, it gets to a point just there where I can actually feel that little lip. Like if I do it over here, it just slides straight off the edge of the chamber like that. If I do it over here, it stops there, and I have to pull harder. Yeah, so there's definitely like a sharp little edge. So I think fixing that and actually improving the extractor efficacy should fix this problem. So what I'm going to do now is I'm just going to get that spring out, and then we'll come back to that with the ironing tool afterwards. I finally pulled that spring out. It's very dry, and as you can see there's sort of grit in there. So yeah, cleaning and degreasing that, cleaning this little pipe thing out. Right, I just carefully ironed that chamber. Now I changed my technique slightly since doing the high standard. I figured that because the chamber iron has some small machining marks, you need to be able to be moving in or out as you do it. So what I did was I went in till it was just started touching the edge of the chamber, then started gently rotating it, gradually put a little bit of pressure on till I could actually kind of feel it pushing the metal, and then while still turning, I kind of pulled it out. And initially there was some resistances, and then suddenly it came out. So that should fix that. And in fact, if you look at that, I can see even now, you can see the edge of the chamber where it's shiny, where the metal has been pushed back. So let's get the brass rod again. So again, feels right there. So there's the bit that was, just turn it around a bit so you can see it maybe. That lip's definitely gone now. So I can, if I slide that up the sides of the chamber, I'll just get it down, just comes straight off the edge. So that's good. So I'm pretty confident that that will fix the problem. Right, I'm just going to want to get this back together, get the extractor back in so I can test it. Now, I was going to try to get a pipe cleaner or something to clean down that hole, but I haven't got around to it. But I just had an idea. One of my old gunsmithing books actually mentions for cleaning down, when you're cleaning a gun, they talk about general maintenance, they're pulling a gun to pieces, then cleaning in all the holes and stuff, they say to use a feather. So this would have been the days before pipe cleaners and all that. So I thought, well, that's something I can try. I've got chickens out the back, so I just went down and I've collected a little pile of feathers. So what I'm going to do is I'm going to get a feather and put a bit of degreaser on it, and then see if I can give it a clean. Right, so I looked for a feather. Obviously you don't want a great huge one with a big thick quill, so I found some intermediate size feathers. I think one of my chooks is molting because they're all the same size. So what I'm going to do is just cut the really thin part at the end off. It won't have enough strength, and then use the sort of part with a thicker quill. So we'll just shove that in there. Oops, shove it in there, give it a twist. I've sprayed some degreaser on this feather. So there you go, it's kind of getting a lot of crap out of there. So I'll get another one and do the same. Got bits of feather floating around everywhere here. All right, so now I've cleaned that with 3 feathers. Now I'm just going to get something with water on it because I want to just put a couple of wet ones in. So this is just removing the degreaser stuff with the oil as well. So I'm not sure if you can see, but just on that left hand pointy bit, just in from that, you can see there's actually a tiny peened edge. If I feel it with my fingers, I can actually feel the sharp edge. So I'm just going to take that off. Alright, so what I did first is that curved surface that wraps around the cartridge, I used a needle file, a round needle file, and I could actually, as I was filing, you'd actually see the little burr that was sticking out was being filed off first. So I just went down until that was gone, and just carefully, I didn't take any metal off, just clean the oxidation off the outside. And then I did the other 2 flat surfaces on the side and on the top. I'll put a bit of cold blue on these before I put it back together again. So yeah, so that should fit nicely in the chamber now, I think. So I'm going to wait and I'm not going to do anything. I'm not going to put it back together again until I get a pipe cleaner, because I want to be able to clean out that hole effectively, get all the crap out of it, so I can get this extractor. I'll degrease and clean this and polish. I'll polish this shaft, probably with I've got some 800 grit here. Polish that shaft so it slides up and down the hole easily. Degrease the spring, clean the hole, clean and degrease the hole, oil it and put it back together again. And you can actually see there's some machining marks on that. So I reckon polishing that will make it go back up and down a lot more effectively. And then we'll fire a test shot and we'll see if it extracts the case, because every long rifle, standard velocity long rifle cartridge I've fired, it hasn't extracted it at all. So if it extracts it straight away, and then it will be a fix. I've just got some 800 grit paper here, and I'm just polishing this to get any just surface corrosion and what have you off it. Polish in both directions. Right, you can see it's got some machining marks on it from when it was made, but that's pretty much as clean as I'm going to get it. So that little notch there is just where the screw sits, so the screw that stops it coming out, so that's sort of the distance the ejector can move. Give that a polish as well. That'll do. Now, the other thing we've got to do is just degrease the spring, and I might degrease this little, clean the little screw as well. So I'll show you how I do that, just degreasing and cleaning small parts. So there's the parts. I'm just going to take them over to the sink. I'll put the plug in the sink so that I don't lose anything down the plug hole. Just give them a spray with the screw degreaser on my hand and give it a bit of a massage, and then just wash them and then dry them with some paper towel. There we go, there's the parts. You can see the spring is much cleaner now. So obviously that spring is semi-compressed, so just dirt and crap between the spring would reduce the efficacy of it. So I'll give that a dry and we'll put it back together. Alright, that's installed. It's a fair bit of tension. I don't know whether it's going to be any improvement having cleaned it, but you know, that case must have been very stuck in there not to have that push it out. Right, so I've put the pistol back together now. I'm reasonably happy with how the whole chamber work went. Of course, the proof will be in the pudding, and we're not going to know till I get a chance to take it out to the range and fire it. Right, here we are out at the range, so we'll have another look at this rifle and see how it's extracting. No problem. Try another one. They just slide straight out, so that one's fixed.